Hi guys, this is going to be the first video of Unit 8. Yes, we are going back in time here. We're going from Unit 10 to Unit 8. I know it's weird. It's just the way that I typically do things. I like to save this unit for the fourth quarter. So Unit 10 was kind of just a shorter unit that I used to fill the break, kind of leading up to spring break there. So Unit 8 is going to focus on rational functions, which are basically big fractions. We're going to start off with the very basics, how to manipulate rational expressions. We'll eventually talk about the graphs and the actual equations for rational functions. But today we're going to keep it simple and pretty short. When we're looking at a rational expression and we're trying to simplify, there's going to be a lot of factoring involved. The first step is we always want to try to factor everything that we can and then simplify from there. We can either simplify monomials with our exponent rules, or if we have common binomial factors, which I'll show you here in a minute here, we can actually eliminate those. So let's look at a few examples. I think that's the best way to become acquainted with these. So this is in a rational expression. Okay, it's basically a fraction. You have a numerator and a denominator, which are both polynomials. So our goal to simplify, remember, is factor and then essentially cancel stuff out. So if we look at our numerator here, and if we're trying to factor, okay, remember we always look for a GCF first, and then if there's more factoring that can be done, we do it. In this case, our GCF is going to be 6, so I'm going to start by factoring a 6 out, and that leaves me with k minus 6. In my denominator, I have k minus 6. So this is what we call a common binomial. I have a binomial of k minus 6 here and here. Since those are common, we can actually cancel these out because anything divided by itself is really 1. So I could technically write this as 6 times 1, which just gives me 6, but that's really the same as just canceling these out. So this whole thing would really simplify down to just 6. Okay, let's look at one that's a little more complicated here. Okay, in our numerator, we have y plus 8, which can't be factored. Okay, the GCF is 1. There's nothing else that can be factored, no difference of squares or anything like that. So then we try to factor our denominator here. So I notice that it's a trinomial, and I have a leading coefficient of 1. So I should be able to factor this fairly easy using our x to factor. Remember, we're looking for two numbers that would multiply to negative 48 and add to 2. Okay, so one of my numbers is positive, the other is negative. They need to add to a positive, so that means that of my two numbers, the bigger of the two should be the positive one. So that means 8 and negative 6 are going to be my choices here. So I'm going to go ahead and I'm going to factor my denominator using these numbers. So my numerator, remember, has not changed. It's still just y plus 8. But my denominator now has factored into y plus 8 times y minus 6. So now I'm sure you notice that we have a y plus 8 in the numerator and in the denominator. So we can cancel those out and see what we have left. Now, really, when I cancel that y plus 8 out of my numerator, remember it's the same as like dividing y plus 8 by y plus 8. So really what's left in our numerator is a 1. And in the denominator, all we're left with is y minus 6. And that would be our simplified expression. Okay, I want you to pause the video here and I want you to try to simplify this rational expression. All right, so in the numerator here, the first thing that I want to do is look for a GCF and then see what else can be factored from there. So I notice that the numerator has a GCF of 2. And that leaves me with r squared minus 1r minus 20. So that's my numerator. In my denominator, I have a GCF of 8. So if we factor 8 out, that leaves us with r plus 4. And then in my numerator, I want to go back and I want to further factor that trinomial, the r squared minus r minus 20. Okay, so I'm going to use my x to factor. I want to find two numbers that multiply to negative 20 and add to negative 1. So that would be negative 5 and positive 4 here. So now we're going to factor again in the numerator. Everything else is staying the same. So 2 times r minus 5 times r plus 4, all divided by 8 times r plus 4. So a couple things we can do here. Okay, my r plus 4s are going to cancel, but I can also reduce this 2 over 8 to 1 over 4. So my final answer would be 1 times r minus 5, which is just r minus 5, over 4. Okay, this is going to be our last one here. Again, I want you to pause and I want you to attempt to simplify this rational expression. Okay, so we have a slightly different type of factoring that we need to do here. In our numerator, the p squared minus 49 is really a difference of squares that would factor into p plus 7 times p minus 7. What I want you to notice here is that the order matters. That 7 minus p that's in the denominator will not immediately cancel out with anything in the numerator. Okay, I can't just cancel that with the p minus 7. Those are very different. What we can do, however, is we can rearrange the order of the terms in the denominator. Actually, I'm just going to erase this here. If I have 7 minus p, that would be the same as writing it as negative p plus 7. And what that allows me to do now is it allows me to look at my GCF in the denominator, which is a negative 1. If I factor a negative 1 out of negative p plus 7, now it becomes negative p, or I'm sorry, negative times p minus 7. At this point, we can cancel the p minus 7. We're left with p plus 7 over negative 1. Okay, but we can just divide both of those terms by negative 1. And our final simplified answer would be negative p minus 7. All right, everybody, I hope this video was helpful. Please let me know if you have any questions, and have a great day.